All right, everyone. So today we're going to continue along in our packet. We are looking at inscribed angles. So go ahead, get your packets out, and let's turn there. So our inscribed angles, we talked about central angles, right, where the vertex of the central angle was in the center. Today, our vertex is going to be on the circle. So here is my inscribed angle. The two sides are chords. So, right, they're not going to be radii this time, but rather they're going to go from one end of the circle to the other. The intercepted arc lies between the endpoints of the angle. So the arc, remember, is the part of the circle. So the arc that is intercepted by the angle is arc AC. So for central angles, the measure of the central angles were equal. This time, these angles are not equal, but rather the measure of the angle is half the measure of the arc. So the measure of the angle is half the measure of arc AC. So if you want to jot this down, the way that I like to think about it is the measure of the angle is half the measure of the arc. And we can flip it, right? We can go backwards with it, and we can say that the measure of the arc is double the measure of the angle. So these are two ways that we can think about our inscribed angles here. If an inscribed angle intercepts a diameter, right? So right here, my inscribed angle on the circle is angle A. If it's intercepting a diameter, well, a diameter is half of a circle, right? So 180 degrees, half of 180 is 90, so it's a right angle. If two inscribed angles intercept the same arc, then the angles are congruent. Okay, so for example, angle ABD, so B, the middle letter right here, is intercepting the arc from A to D. Well, from A to D is also intercepting this angle, ACD. So those two angles would be congruent. So let's try a few examples. So the measure of the angle is half the arc, or the measure of the arc is double the angle. So we're trying to find the angle measure. So the measure of the angle is half of 62. Oops. 1/2 of 62, 31 degrees. For number 2, I'm trying to find the measure of arc DGF. So I'm trying to find the measure of this arc. So the measure of the arc, right, like we set up here, is double the measure of the angle. So we're going to double 113, 226 degrees. Angle PQR, here that middle letter at Q, this is a diameter, so that means Q is a 90-degree angle. Number 4, we want to find the measure of arc B to C. Now, how do we do that? Well, we know the angle right here is 47, so its intercepted arc is double 47, that's 94. This is a diameter, so this is half of a circle, so 180 minus 94. We get 86 degrees for the arc. So what's different about 3 and 4, right? There's a diameter in 3, there's a diameter in 4. We're looking at the angle and its intercepted arc. So for number 3, we were looking at angle PQR right here. So the angle is formed with the intercepting diameter P to R. For this one, we were given angle B. Let me erase this. We were given angle B, which was 47 degrees. We were trying to find arc BC over here. So if we were looking for angle C and it was connected to A, that would be 90 degrees because that angle would intercept the diameter. Okay? Number 5, we're trying to find angle JKL, so the angle right here. If we're trying to find this angle, we need to know its intercepted arc. So we need to know arc JML. And we can do that because we know a full circle is 360. 360 minus 53 minus 65. This arc is 242. Remember, the angle is half of the arc. So we take half of 242 and we get 121. Number 6, this is an example of our overlapping arcs. So we have angle RST, R to S, that middle letter, and RUT, that middle letter. These are going to be the same angle, but we need to know, right, its intercepting arc is right here at, let me use a different pen. The intercepting arc is at RT, so we need to know what arc RT is. Now, how do we do that? Again, we know the rest of the circle, 64, 139, and 75. So subtract all of those from 360. So this arc is 82. Take half for the angle. Both angles are 41 degrees. All right, now I'm going to help you with the first one, number 7, and then I'm going to let you work on the rest of these on your own, setting up your equations. So remembering that the arc is double the angle, and the angle is half of the arc. So really, you can double or you can take half. I personally like to double, so I'm going to use this up here, that the measure of the arc, so 158 is the arc measure, is double its angle measure, 8x minus 9. And so now I'm left to solve this equation. I guess I can make that bigger. 158 plus 18, 176 equals 16x divided by 16. X equals 11. Whether you double or whether you take half, you should get x equals 11. Okay? So we're going to pause the video, and you are going to work through 8 and the back side, and then we'll move on to quadrilaterals. All right, last little bit for today, inscribed quadrilaterals. So quadrilateral, right, four-sided figure. If a quadrilateral is inscribed in a circle, right, so we have a four-sided figure in the circle, then its opposite angles are supplementary. Okay, so opposite angles are supplementary. So in this instance, angle A is opposite angle C, so angle A plus angle C equals 180. Angle B is opposite angle D. Angle B plus angle D equals 180. And that's all we do for inscribed quadrilaterals. So number 1, opposite J is L, 92. So 180 minus 92, 88 for J. Opposite K is 45. 180 minus 45, 135 for K. In number 2, in the quadrilateral, I'm only given Q. So opposite of Q is S. So I'm going to find S first, 180 minus 93. and I get 87. P and R are opposite each other. They are also supplementary. However, I need to find one of them before I can find the other one. And so I'm going to do that by using what I know about inscribed angles first in this example. So R right here is an inscribed angle of 126 and 90. So 126 plus 90 is 216. So its arc measure is 216. So its angle measure for R is half of that, which is 108. Now, P and R are opposite each other. They are supplementary. So 180 minus 108 should be 72 degrees. So sometimes we have to use what we know about inscribed angles here. And we're going to do the same thing for number 3. We're going to use that D because we don't have any angles in the inscribed quadrilateral, but I know that D, that's the easiest one to spot, is formed by 39 and 61, which is 100. So half of 100, angle D is 50. Angle B is opposite angle D, so 180 minus 50, 130 for angle B. Now we can do the same thing with A or C. If you look at C, you're missing a arc AD. You can find it because you know the rest of the circle. But since I already know for A that it's inscribed from B to D, so 61 plus 147, that's 208. So half of 208, 104 for angle A. Angle C is supplementary, minus 180, 76. Okay? So using what you know about inscribed angles and now opposite angles are supplementary to solve your equations for x. Number 4, opposite angles are supplementary, so I'll set you up. 9x minus 5 plus 68 equals 180, and we would solve for x. So I believe now you can finish the rest of this page. And the next page is, in fact, your homework on inscribed angles. Yes, we are doing the front and back side, checking it tomorrow. Continue working for the rest of the class period, and I will check your homework tomorrow. Have a great day.